I can see there are 92 participants. Okay, so let us start. We'll start with one very simple poll for half a minute. So go on answering on poll. The question is: parent terminates before child process, then child process is called as zombie, orphan, or null. Last 15 seconds. 5, 4, 3, 2, 1, 0. Right. So the poll results, yes, you can see 40 students are saying it is orphan, which is correct answer. 25 say zombie, that is wrong answer actually. And still there are 4 students saying it is null process. No, there is nothing like null process. Okay, so this is exactly there on the slide. If parent terminated without invoking wait, that process is an orphan. Okay, actually no need to mention this word also, without invoking wait, because if it has invoked wait, then parent will not be terminated. It is waiting there only. So no need to mention that actually, without invoking wait. Whereas if no parent waiting, the meaning is parent is there, it is alive, it is doing some sort of task. The thing is, it is not waiting for the child process. So it is not there to get the status of, that is the exit status of the child process. So zombie is like parent is not terminated, but it has not invoked wait for the process. Now then such a process is called as a zombie, because the child process still is waiting to convey the status. That is the case. Okay. So I guess it is clear. I think yesterday I shared the program also. What is zombie and what is orphan? So for example, if I given say some sort of a sleep statement in the parent process, or maybe parent invoked some sort of infinite loop. In that case, if it is infinite loop, that means it is doing some sort of task. Only thing is that is not waiting for the child process. That is about process termination. Do you have any doubt on this zombie and orphan? Because this is somewhat tricky, I can say, somewhat tricky. Yes, is there any doubt on this? Do we continue? Fine. Let us move to the next slide. Now, multi-process architecture, an example they have given is the Chrome browser. Like single application still can have multiple processes. That is one of the example in front of us, Chrome browser. So most of the web browsers earlier days, they are actually executing as a single process. Even still also there are few. Maybe the browsers, those supports multiple tabs. For example, Chrome, you can open different tabs, right? So each and every tab is implemented as a process or thread, or it is managed by a single process only. Okay. Let me tell you the problem with, say for example, if there is any trouble with any of the website in any of the tab, then entire browser will crash, it will hang. That is the problem. But if the architecture of that browser is in such a way that each and every tab is implemented as a separate process, then if there is a problem with any website, only that website will have trouble and no others. Okay, so that is the case. So for example, if you think of Google Chrome, it is a multi-process with three different types of processes. One is the browser process, which manage the user interface, disk and network input output. So if it need to fetch something from a remote web server, that is network IO. Okay. Next is renderer. Now whatever is fetched, that has to be rendered on HTML page. Okay. So it is actually hypertext markup language. So for example, in Angular bracket B and then some text and /B. So opening tag, then text, and then closing tag is there. Actually, we don't see B and /B, but we see whatever the text in between this tag in boldface. Now this will be rendered by a separate process called as a renderer. Not only HTML tags, but also it deals with your JavaScript, because JavaScript is executed at the client side. Okay, so usually it runs in sandbox. The meaning of this sandbox is if there is harmful code, then it don't hamper the execution of other applications. Okay, so very restricted access is given. So that is the meaning of sandboxing. Of course, I guess most of the students already aware the concept of plugin. So Chrome makes use of separate process for each type of plugin. So, say for example, if you installed a spell checker, right? Then maybe downloaders. So many plugins are available there. Now, this is third category of the processes used by the browser. The thing is, if we have multiple tabs, if there is problem with any one of the website, this don't hamper execution of others. Other processes do not have. So complete browser will not hang, right? That is advantage. Now next is the important part, inter-process communication. For this inter-process communication, I don't know whether I should talk about thread right now, because most of the IPCs can be implemented with processes also and with threads also. Fine, let us first of all finish the theoretical discussions on the IPC, that is inter-process communication. Now, very first thing is regarding the very first line. Okay, this is regarding the relationship between the processes. Now, what is this relationship? Say, for example, forget about relationship like parent and child relationship. Yes, of course, that relationship is there, where parents have more privileges than the child process. So that is definitely there, no doubt about that. The thing is, when two or more processes are working or they are solving the same problem. Like for example, you imagine where very lengthy mathematical computation is there, and that is divided between multiple processes. So actually multiple processes are working on the same problem. That means they are cooperating. So that relationship is cooperation. It is mentioned here. The processes are cooperating with each other. Does somebody want to ask anything? Yes?
Some students are having problem while joining through desktop app.
I guess 109 participants are there.
Yes,
And
sir, still 2-3 people are not are using desktop app, so they can't join.
I can see many students are there. They are still using desktop app because I don't know, because there is no separate setting here, and even limitation is also not there. For example, let me tell you. Are they using a browser or app?
No, sir, desktop app.
Ask them to use browser. Abhishek Bhosle is there? Who is Abhishek Bhosle? I can see Abhishek Bhosle. Yes, Abhishek Bhosle. You are using what, mobile or desktop? Because icon here showing is desktop, not mobile. Abhishek Bhosle, are you there? बहुतेक लॉगिन होऊन गायब झालाय का काय कळत नाही आहे. For the sake of attendance, Abhishek Bhosle, you are not audible. You can put something on chat. You can put something on chat. Only change I done today is rather than using WebEx meeting, I selected WebEx training. It has some additional features, so I selected that. Otherwise, see, 111 students are already joined. Attendee asked a question.
So even I think using mobile phone.
Abhishek Bhosle is saying yes, sir. Abhishek Bhosle, you are using desktop or mobile? He is using desktop. He answered in the chat box. He's using desktop because I can see that here.
Okay, sir.
So I don't think any issue is there. Maybe they have some network connectivity issues. Okay.
Okay, sir. I'll tell them.
Okay. कारण 111 जण ऑलरेडी लॉग इन झालेत ना, तो काय तो वेगळा असायचं काही कारण नाही. ठीक आहे. So let us talk about the cooperation between the process. Like if one project is given there for the student and 5 students are working on the same project, that means they are solving the same problem. So they are cooperating each other, right? So that is what the meaning is. They are actually cooperating with each other. Similarly, if multiple processes are working on the same problem, the relationship between the process is like cooperation. Okay. Whereas if two processes are doing their own task, they are not related with each other, not just in terms of parent and child, in terms of anything. Okay, like one is doing some other task and other one is doing some. Let me give again more practical example on this. Say for example, I am preparing my resume, making use of any word processor. I am typing there, and if I do some sort of spell mistake, spell checker will automatically highlight the word. So actually, that is cooperating with the word processor. That is a cooperating because everybody is doing the helping the person to type in correctly. Whereas, for example, I am preparing my resume using word processor, and at the same time I am listening to the music. So that process is also running, but that process has nothing to do with the word processor. In that case, we can say it is independent process. You got both the things? The processes like cooperating processes will be there and independent processes are there. In cooperation, maybe processes are very simple example. I need to do something like some operation on 100 numbers and 4 processes are there. First process will select first 25 number, second will do on next 25, third will do on next 25, and fourth process will do on whatever the operation, last 25 numbers. That is what the cooperation is. Okay. And now always remember, whenever independent processes are there, in that case, whenever independent processes are there, in that case, what happens is they are containing for the processor. So they are actually there is a competition between the processes to gain access to the processor and finish whatever task is given as early as possible. That is not true in case of cooperating processes. Okay. The second thing is the cooperating processes, they can affect other processes or they may get affected by other processes, including like sharing of data. So we need to share the data. Just I give an example, some sort of operation on 100 numbers, then whatever the numbers, maybe another process is taking input from the user and putting that in shared buffer. I'm saying shared data now. And that data, out of that, maybe first 25 I have taken by process 1, next 25 by process 2, so on and so forth. So there is definitely effect of one process on other process. What are the top reasons for the cooperating processes? Why to do this cooperation? Okay. 4 reasons are mentioned here. Very first is information sharing. Whenever I want to share some sort of information with other process, then definitely cooperation is required. Like for example, whatever the app you are using right now to attend the lecture, that is also one process on your device's operating system. Whatever the process I am using on my computer, on my laptop, that is also a process. Now they are now cooperating. Whatever I am talking, whatever I am sharing, it is conveyed to you. It's kind of a sharing. Okay. So that is one of the reason is information sharing. Second thing is computation speed up. What happens in computation speed up? For example, just imagine the same example again. There are 100 numbers and I want to do some sort of operation on that. Now if I have say quad core processor, if it is a single task, then what will happen? Single core has to perform operation on all 100 numbers. But if I have quad core, 4 cores are there, fine, I can create 4 processes or even for that matter 4 threads also. So 4 processes can be created. Every process will acquire one processor and they will perform the operation on say bunch of 25 numbers. So definitely time required to perform the operation on 25 number is less than the 100 numbers. It is very obvious, and that is the reason the computation speed up. So this is one of the reasons for cooperating the processes. Next one is their modularity. Okay, modularity. Let me tell you, give example. Most of the time we fill up so many online forms, right? Earlier days when say FoxPro or COBOL like languages are used to prepare this kind of form, even if you visit the railway reservation system, there also still those text-based kiosk handling panels are there where you need to go in sequential manner. So whatever the first field is there, you first of all fill that, then move to next, then next, and then at the end you have some sort of action keys, something like hit enter or press Control S or maybe F1, F2, whatever. Okay, and then the actual action will be performed. So for example, if it is pre-filled with some default values, say 20 different fields are there, and I just need to modify say 17th field, first 1 to 16. I just want to keep as it is. How to move there? No, there is no way there. But now with modern user interface, you just make use of your mouse, go anywhere in any of the field, click there, just fill that field. If others are not mandatory, you can finish the. So now, where is modularity here? Let me tell you, whatever your controls are there, they are designed in some sort of modular ways. Even whenever we see the classical problems of this IPC, not just IPC, even inter-process synchronization also, then you need to know, like, rather than doing everything by single process, it is better to divide that problem into small functionalities, procedures, and implement them as separate modules. So modularity is one of the reasons for cooperating processes. Even as I mentioned, the convenience for typically for the user interface. Okay. Now, cooperating processes needs this IPC. Why this IPC is required? Even if I repeat the same example, performing operation on some set of 100 numbers, then even though I said 4 processes are there, which will take say bunch of 25 numbers, the thing is one process has to collect all 100 numbers, maybe from user, maybe they will generate it randomly, and then convey these numbers to 4 processes. Like first 25 will be given to first process, last will be given to 4th process, something like that. So I need to convey. So that is the communication. Even whatever the sub result is there, I'm not saying direct result, sub result, because 25, then next 25, then next 25, and then last 25. So 4 sub results will be there that need to be combined. Say if it is example of say addition, I'll get subtotal. So 4 subtotals will be added, and then final addition will be there. So one process has to convey number, that process has to convey result, so on so forth. So cooperating processes needs some sort of inter-process communication. Okay, and for this inter-process communication, that is the IPC. 2 models have been suggested. One is shared memory model and one is message passing model. Where meaning of shared memory is like each and every process. Say suppose this is process 1, so this is process 1. It has its own memory. This is process 2. It has its own memory, right? Then in system I can have a shared memory segment which is not part of P1, which is not part of P2. Then this will be attached to this process also, like P1, to this process also. Now this made accessible by P1 and P2. So whenever P1 writes something here, that can be read by process P2. And that is the inter-process communication. So that is possible with shared memory. Now, why shared memory? Like why P1 cannot access memory segment of P2, even vice versa. Why P2 cannot access memory segment of P1? That is for a security purpose. Processes have their own memory space. They are not supposed to share their memory If explicitly required, then we need to declare a separate memory segment which is accessible by P1 also and P2 also. Even multiple processes can access it. So this model is, anyways, we are going to see the details like what are the different system calls available in C language also, and how the shared memory is possible. Because there is a separate unit on interprocess communication, separate unit on interprocess synchronization. Okay, in this unit, just we want to talk about the processes, why they need the communication between the processes. If they are independent, definitely it is less required. Rather, I can say it is not at all required. But if the processes are cooperating with each other to solve the common problem, they need to have communication. I'm not saying it's always required, but they are cooperating, then inter-process communication is must. And how to provide this inter-process communication depends on the designers of operating system. So two models are mainly popular for inter-process communication. One is called as shared memory. Second one is called as message passing. Okay. So one of the practical example I can say shared memory is, see, notice board. So whenever department want to share something with the student, what department does is they will put the notice on the notice board. So you can imagine notice board as a shared memory which has access by all, right? Now maybe we'll protect that so that student only have the read access, okay, and department may have write access to it. That means they are putting. So anyway, we are going to see details of that, but this is the classic example for the shared memory. Department puts notice on the notice board and student reads it. So that is a good example for a shared memory. So notice board is the shared space between the department, say faculties and the students. If you imagine they are processes, one student is one process, another student is another process, one faculty is one more process. So each and every individual is process. Keeping that thing in mind, I can say notice board is shared memory. Whereas message passing is there. Message passing. Okay. So now what happens in case of a message passing is, rather than putting it on say shared memory space, maybe shared by all, maybe we can, like, say for example, we send message on WhatsApp or we send individual mail, right? So that is the way of message passing. Or maybe we read the notice in a classroom. That is the message passing, I can say. Okay, so there are two different models of interprocess communication. The same thing is mentioned here. First one is, now here message passing is given and here it is shared memory. So this is the memory segment of process A, this is memory segment of process B, and separate shared memory segment is there, and process A is attached here to the shared memory and process B is attached here with the shared memory, something like this. Whereas what happens in message passing is we have a separate message queue, and then process A will put its message in this message queue. So like message 0, 1, 2, 3, 4, whatever, n number of messages are there. Okay. Actually, this arrow should be bidirectional. So process can read message also, process can write message also. Something like this. Any doubt in this? The communication models. Now, how they are implemented, it depends on different operating systems. Anyways, that we are going to see practically also. So we are writing program with messages also. We are writing program with shared memory also. Fine. Let us continue. I think this is again repeated here. Independent processes cannot affect or to be affected by the execution of another. Cooperating processes can affect or affected by execution of another. Advantages, yes, we already discussed this part. Now, this is one problem. Anyways, right now I'll just share the problem, and solutions we'll see later on when we discuss IPC. Because in order to provide solution, first of all, we need to have the practical knowledge of how to implement. So this is one of the classical problems. So whenever you think of operating systems, synchronization and communication, there are few problems. They are always discussed, and this is one out of them: producer consumer problem. Okay, so there will be n number of processes. That is very first thing. So I can say n is, for example, say 10. So 10 different processes are there. Out of these n, there are some p number of processes. We call them as a producers, and c number of processes we call them as a consumers. So if I say n is equal to 10, then p and c not necessarily 5 and 5. Maybe there are 6 producers and there are 4 consumers. Okay. Now what happens in this is, you imagine this like this is one set of processes, and consumers, this is another set of processes. Okay, not necessarily same number of processes. Now the first set of process will produce some sort of information. So producers, as the name suggests, the producer process will produce some sort of information, and that will be stored somewhere. Next, so it is something like they will produce something, and that will be stored somewhere, right? And consumer are the processes, they will get or they will consume the information from the same thing. So the name or the categories of processes are very simple: producer and consumer. Producer produces the information, consumer consumes the information, and that information could be anything. Say for example, producer will produce some sort of random numbers. Okay, producer will produce some random numbers, and now consumer will consume those random numbers. You may wonder here, what is problem then? Right? Producer has produced and consumer has consumed. That is fine. What is problem here? The problem here is you need to devise the solution in such a way that the order of items produced and order of items consumed should be the same. And whatever this buffer is there, the space where the produced items are stored, or the space from where consumer consumes the items, this is called as a buffer. And typically it is two types of buffers. One is called as a unbounded buffer. Unbounded is something like infinite, which is practically not possible. Okay, so it places no practical limit on the size of the buffer. No limit is like infinite. Whereas bounded buffer, when I say bounded buffer, that means there is some sort of capacity for this, some sort of size is there. Size S or S I Z E. Right? There's limit, whereas unbounded is there is no limit. Now, for example, you imagine something like 6 producers are there and 4 consumers are there, and size of this buffer is just say 5. That means we can put 5 elements here. We'll assume that first producer produced 1 item available in this because there is a space in the buffer. Second producer, third producer, fourth producer, fifth producer, fine. When 6th producer is selected, now the buffer is full. Now that producer has to wait for space. Now whenever I say waiting for what? Producer is waiting for what? So producer is waiting for consumer now. Why consumer? Because whenever consumer consumes or takes away the item from the buffer, space will be created there. And once space is created, now producer can produce next item. So this is one of the classical problem of interprocess communication and even synchronization. Now why synchronization? Because execution of producer depends on consumer, execution of consumer depends on producer. So they are all cooperating processes. That is important word here. In producer consumer problem, the relationship is cooperation. Cooperating processes are there. Okay. The order is important. Say for example, if I created 4 consumers and 6 producers and consumer is selected before the producer, what will happen? Consumer has to wait for very simple reason. There is no item available, not a single item produced by the producer. Consumer cannot produce anything. And producer also has to wait if the buffer is full. Otherwise, what will happen? It will get overwritten. Right. So this is one of the typical problem of interprocess communication and synchronization. The producer consumer problem. Okay. Any doubt in this? If you have any doubt, yes, please put on chat. I think this time you are not getting chat, but it is Q&A, question and answer. Right? Fine. Now the same thing, how that problem is written in terms of pseudocode, the producer and consumer thing. So for example, buffer size is 10 here, so definitely this is bounded buffer. Then some sort of item as I mentioned. So like this is code from C language. I guess you already understood this. This is type def struct, some type of structure. If I say I want to create integers, so maybe I'll say int here with some sort of variable, say maybe int a or something like that. So my item becomes a new data type, right? And then how buffer is created is something like this. Buffer can hold buffer size items. Okay. And then there are 2 indices used here, in index and out index, where in index will be used by the producers. It is something like I will produce the element and then buffer of in is equal to element, buffer of in, and then in plus plus. Why in plus plus? Because maybe initially it is 0, so I'll put something there and then that's it. I'll put the element at 0th element and then plus. It is exactly same like if you remember the circular queue. Circular queue. Exactly same thing. So you need to implement the circular queue, but not with single process now, with multiple processes. That is the main challenge here. Multiple processes, and one set of process inserting something into the queue, and other set of process they are removing something from the queue. Exactly same. Like I guess in circular queue you are making use of front and rear, where elements can be added from the front end or rear end. Rear end. Yes. Anybody? Let me put that question on poll. Let me add the question. In circular queue, elements can be added from which end? And let me give some options there. Yes, please respond to the queue. Last 15 seconds. You see the result. 9 students saying from front end, 44 are saying from rear end, and interestingly, 29 students are there. They are saying randomly anywhere, which is 100% wrong. Okay, it is a queue. It is not priority queue. I mentioned circular queue, so definitely it has to follow some sort of discipline while entering and exiting from the queue. So the correct answer is rear end. Okay, exactly same way here, just the things are in and out. Producer will make use of in, that will be for adding the elements, and out, that will be for removing the elements. So you can simply imagine like in is rear end and out is front end. That's it. Okay. Okay. So solution is correct, but can only use buffer size -1 elements. Still synchronization code is not mentioned here. So that is what the bounded buffer shared memory solution. Now what producer will do is very simple thing. Remember this is pseudo code, so maybe it will work or maybe it will not be work. Reason being that is if you convert it to C language, yes, most of the things are like in C language, but synchronization code is not there. Okay, so item next produced. So producer process now. It is not single process, multiple processes will execute this code. Next produce, so this is the variable which will hold the value of item produced next. Okay. Then here you can produce the item. Here there's a, this is a placeholder. Now for example, as I mentioned, so randomly, maybe you will make use of random function there. Okay. If you want to take it from say user, no problem, you take it from user like using scanf. But typically don't make the programs interactive, otherwise you don't get any uh, side effects of that. You need to say that. Okay. Once item is produced here, now what is this? Can anybody tell me what is this? The condition is mentioned there. In plus 1 mod buffer size equals out, do nothing. What is meaning of this? This is the condition for queue full. How to check whether the circular queue is full or not? This is the condition. Okay. And if the queue is full, do nothing. That means you have to wait there. Remember this while loop, there is not a single statement in the while loop. Just semicolon is there, do nothing. So until there is a space, it will be in the loop only. Somebody has to modify it. And if there is a space, then buffer of in index is next produced. So whatever item we produced at this location, this item will be stored into the shared buffer. And now my in index will point to next. Why this mod is used? To make it circular. So say for example, if it is 5, so it becomes like 0, 1, 2, 3, 4. After 4, again it comes back to 0. So 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, something like this. So it's a circular manner. Okay, so this is the code. Still, this is not complete code. Okay, so this is the code for the producer process. This is the code for consumer process. Item next consume. So here this is a variable. Item is type of data that we declared with structure type def struct. So next consume, this is a variable to hold the item consume from the buffer. While in is equal to out do nothing, this is the condition for queue is empty. Okay, queue is empty. If the queue is empty, do nothing. Somebody has to produce the element and then only it will consume it. That is what the meaning is. Okay. If the students can see this red exclamatory mark in the participant, meaning of this is they are less attentive. And anyways, some sort of AI based algorithm is used, I guess, by WebEx. Like for example, if you log into the meeting and if you simply minimize or if you are doing something else, automatically this software makes this exclamatory mark there. And I can see lots of exclamatory marks there. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 13 I can see at least. Okay. Now here for the consumer, if buffer is empty, do nothing. That means just wait for the producer process. If it is not empty, that means you are not waiting in the while loop. You will take the item outside of this buffer, making use of this out index. So buffer of out is assigned to next consume, and then like in is modified, out is also modified in circular fashion. So out is equal to out plus 1 mod size of the buffer. Okay, and then whatever the operations you want to perform on the consumed item, so the other task is there. So this is one of the classical problem, that is producer consumer problem. Two sets of processes, Producer produces elements, some sort of information, consumer consumes that information, order of that must be matched, like order in which items produced should be the same order in which items consumed. Items can be stored in the buffer. If buffer have no limit, we call it as an unbounded buffer. If there is limit, then we call it as a bounded buffer. So how it is represented in any programming language is something like this. This is the buffer size, so bounded buffer. This is item of buffer. What kind of item is there is decided by the structure. Two indices are used, in and out, and it is the circular queue fashion. Okay, this is the pseudocode for producers, and this is the pseudocode for the consumer. So I guess we are running out of time, so we'll stop here for today. We'll continue tomorrow.